Dear students, in previous classes we have seen what is average value and what is RMS value and uh, we have derived the expression for average value and RMS value for sinusoidal waveforms. Now in today's class let us discuss how to find out the average value and RMS value and form factor for a given waveform. Let us consider the problem shown here. It has been given that determine the average value, RMS value and form factor for the current waveform shown in figure. So what are the current waveform that has given in this figure? For this waveform, we need to find out the average value, RMS value and form factor. If you observe the waveform, it is asymmetrical waveform. From 0 to 2 seconds, the magnitude of the current is 10 amps. From 2 to 3 seconds, the magnitude is 0. And then again from 3 to 5, the magnitude is 10 amps. And then from 5 to 6, it is 0. So the waveform is repeating for every 3 seconds. Therefore, the time period t is equal to 3 seconds. 3 seconds. Now let us see how to find out the average value. The average value is given by area under the curve divided by base length. Base length. So here from 0 to 3 we are having one cycle. So I am considering the entire cycle as it is asymmetrical waveform. So the base length is 3 seconds. Now if you see the area from 0 to 2 seconds, it is of rectangle type with a length of 10 and width of 2, and then from 2 to 3 it is having a magnitude of 0 with a time span of 1 second. So average value is 20 by 3. It is 6.67 amps. Now if you find out the RMS value, IRMS is given by square root of area of squared current waveform divided by base length. So the IRMS is given by square root of, if you see the area of the curve from 0 to 2, the magnitude is 10, so I is 10 and hence I square is 10 square into time period is 2 plus from 2 to 3 magnitude is 0, so 0 square into 1 divided by total base length is 3. So it is equal to 10 square is 100, 100 into 2, 200 by 3 whole under root. So root of 200 by 3 is equivalent to 8.165 amperes. Now we need to find out the form factor. So the form factor Kf is given by RMS value by average value. Therefore, for our problem, Kf equal to RMS value is 8.165 and average value is 6.67. Therefore, the factor is given by 1.224. Now, let's see one more problem. So, in this problem also, they asked determine the average value, RMS value and form factor for the voltage waveform shown in figure. So the same quantities as we have done in the previous case, we need to find out the average value, RMS value and form factor, but instead of current waveform, now they had given in voltage waveform and the time is given in terms of milliseconds. Now let's see what is the time period. So if you observe the waveform, this waveform is repeating for every 20 milliseconds. From 0 to 20, magnitude is 20. From 10 to 20 milliseconds, magnitude is 10 volts. Next, next 20 seconds, 20 to 40. From 20 to 30, it is 20 volts. 30 to 40 is 10, similar to the first cycle. Therefore, the waveform is repeating for every 20 milliseconds. So the time period is 20 milliseconds. Now you find out, we need to find out the average value. Let's see average value. V average is given by area under the curve divided by base length. Therefore, V average equal to, from 0 to 10 milliseconds, it is having a magnitude of 20 and the time duration is 10 milliseconds. Milli is 10 power minus 3 plus, next, if you consider this duration 10 to 20, it is having a magnitude of 10 volts for a duration of 10 milliseconds, and the total base length is 20 milliseconds. So if you simplify 20 into 10, 200 plus 10 into 10, 100, and if you take 10 power minus 3 common, then 1 second, it is 10 power minus 3. Denominator is 20 into 10 power minus 3. So 10 power minus 3, 10 power minus 3 gets cancelled. We are going to get 300 divided by 20, 0, 0 gets cancelled. 15 volts we are going to get as average value. Now now let's see the RMS value. So VRMS is given by area of squared voltage wave, that is area under the square voltage waveform divided by base length. So VRMS is given by, for first 10 milliseconds we are having a magnitude of 20 volts. So 20 square magnitude square, 20 square into time duration 10 milliseconds, 10 into 10 power minus 3 plus, for next milliseconds we are going to have 10 volts. So 10 square into duration 10 milliseconds divided by base length is 20 milliseconds. So if we take 10 milliseconds as common in the numerator, then we are going to get 10 into 10 power minus 3 into 20 square plus 10 square divided by 20 into 10 power minus 3. 10 power minus 3, 10 power minus 3 gets cancelled. 10 1 jar, 10 2 jar. So we are going to get square root of 20 square is 400 plus 10 square is 100 by 2. So it is equivalent to square root of 500 by 2, which is square root of 250, which is equal to 15.81 volts. This is RMS voltage of the given waveform. VRMS equal to 15.81 volts. Now we need to find out form factor. The form factor Kf is given by RMS value by average value. So VRMS by V average. So Kf equal to RMS is 15.81, and average value we have determined as 15 volts. So 15.81 by 15, it gives 1.054. This is form factor. Thank you.